welcome back to the Arduino exploration. Thank you very much for joining us for lecture number 4. I hope you've been enjoying it so far and you haven't found it too challenging or too difficult. I promise you, the further we get into the material, the more interesting it will become, and then we'll be touching into more projects and see how things work with the Arduino and its capabilities and possibilities, what we can do with it. I hope the last exercise wasn't too challenging for you, and I hope everyone succeeded. I just wanted to touch on a couple of points regarding the last project. The very first one, and probably the most important topic around the coding part of Arduino. Never worry about how messy your code is. As long as it works, that's fine. As long as it does what you want it to do, that's great. The second thing is I wanted to say about the code. It can be very long, it can be very short. There's no single way of writing what you want the Arduino to do. There's always multiple ways of approaching the same problem or approaching the same project. So don't worry if your code was different, as long as the result was the same, where you got the blink from the Arduino lights, sorry, not the Arduino, the LED lights. And I hope you experimented a little bit with the delay also. That would give you a bit more of an idea what the delay will do, how long it is, and it's just a bit more fun to play with it. Maybe you even made from red and light like a police sirens, but I hope that it was quite enjoyable and you all succeeded. So let's just have a quick overview of this lecture. The very first slide will talk about multi-line comments and single-line comments and how we use them and why we use them. And we'll also explain a little bit about the semicolon and what it does within the code. I do apologize, there's a slight mistake around here, but it will be changed as we get into the material. The very next slide is the answer to exercise 1. The way I did it the very long way, but I'll touch on it as well. Then we'll have a very short video of my result and how I constructed my circuit. Then we'll talk about the common operators that are used within Arduinos and how we use them within our projects. It's not going to be in this presentation, but we will touch on it a little bit later and we'll see how useful they are. There's also mathematical common operators and logical gates as well. The logical gates you don't need to worry about as of yet, but the mathematical one is simple stuff, so I'm sure no one's gonna have any difficulties understanding them. And then we're gonna touch on something very interesting. It is a function within the Arduino IDE. It's a serial port, and we'll talk about the serial port, how we can use it, how we communicate with it, and why we need it. So let's jump into the very first slide, and we'll start from the actual comments within the code. So again, we start with the comments within the code, and as I said, there are two types of comments which can be used to leave notes for the future reference. Why would you use the comments? First of all, obviously the comments are there, so for example, if you write a piece of code and you want to share it with someone, then the person who's looking at the code, rather than trying to understand what is happening, and it might take a while, they can read simply the comments and understand, oh, okay, this part is doing this part is doing that. So that's why comments are very helpful. Obviously, for yourself as well, it is very helpful because not all of the codes can be written in one go. For example, sometimes you need to go away and think about something, or you need to go on the internet and research a couple of things. And when you do that and come back to your code, you might get puzzled, or you might forget, oh, why am I doing here? Why am I doing there? So leaving a comment is very useful. At this stage, I don't see the necessity for leaving comments as of yet because the codes are quite simple and it's quite easy to distinguish what we're doing in each part of the code itself. As I said, there are two types of comments and we'll demonstrate them on the code itself. We have the multi-line comment, which is defined by /star, and then whatever is between the /star and */ will be commented. So you will see it, it will be grayed out. Let's have a quick example on our Arduino code. Let me just delete that one and you'll see the difference. So this is the answer to the exercise I set up for you last time. And let's say I want to comment the top part, or I want to disengage from the top part for some reason. So I'll just do /. This, you see that it selects all of the code, but obviously I want just certain part, and I'll close the bracket and you can see this is grayed out, so it's not going to be used within the code. If I try to verify it, it's going to give me a problem. It's going to give me an error saying LED1 was not declared in this scope. It's because it's under comment, so we can delete that. This is one way to use it. If you need to, this is very useful if you need, for example, to write a piece of something, let's say, in between the code. So just a quick example, we'll do the /*. As you can see, it's already predefined that this is a comment section. This part of the code is executing commands to, and as you can see, I can use the enter and it will go to the next line and it will still be under the comment. This part of the code is executing commands to activate the LED in sequence. And that's it. If we compile the code now, the text is not gonna matter. It compiled correctly, no problem at all. So let's have a look at the second one. This is a single line comment and it's defined by 2 /. Very useful. Obviously, if you don't need to write a massive amount of explanation what it does, we can just go 2 /. This activates the LED1 and LED2 deactivated. Just a quick notice that you don't need to close the 2 /. It will just comment anything after the 2 slashes until you go to the next line. So if you write here, you can see that this is not grayed out anymore because there's no 2 /. in front of it. We'll just compile the code just to show you it is working correctly. Compiles absolutely fine and we can work like that. As I said, it's good practice. Do comment on the code. Just, even if it's a small comment, this function is doing that, this function is doing this. It's a good practice for future reference. It will be much easier for you to write a code and comment on it. And for the final one on this slide, what is semicolon? So the semicolon is the full stop and semicolon itself, and it defines lines of command. And what we mean by that, when we speak to the Arduino, it needs to know where the line ends. So instead of a full stop, it uses the semicolon, and the semicolon says, okay, this line is finished, go to the next one. This line is finished, go to the next one. That's all it does, the semicolon. So let's just jump into the answer to exercise 1, which we set up for you to do in presentation number 3. And this exercise was to aim for you to activate LED lights in a sequence. It was no matter which sequence they go by, from 1 to 5, from 1 to 4. I did it with 5 LEDs, and that's how my code looks like. As I said, it doesn't matter which way you write the code. This code could have been written in a shorter way, but I just wanted to define it in a long way so you can see the step by step what in principle the Arduino does. So what I did, I interpreted the LED 1, 2, 3, 4, 5, and I gave each one of them a port number. In the port, obviously 3, 4, 5, 6, 7. Then in the void setup, I set all of them to be an output because obviously we don't take any signal from them. They're only displaying something to us, hence they're all output. And in the void loop, I just repeated the code 5 times, and in each of the repetition, I stated which LED will be in the high state, while the rest of them are in the low state, which means they're switched off and the high state is switched on, and then a quick delay between them. And that gave me a perfect sequence of LED lights going up and down and then repeating up and down from number 1 to number 5. I also wanted to ask you how you wrote your code within this exercise, and if you can post your answers into the Facebook group, that would be great. We can have a look at them and give you a little comment on what we think or how you did it and how brilliantly you did it as well. But as I said, there's another way to write the code which is quite simple as well. So just on the next slide, we just want to show you how we did it, the configuration of the LEDs and the Arduino itself. So as you can see, this is the working prototype of the blinking lights. There's 5 LEDs connected to the Arduino board, and the Arduino board has the uploaded code which was shown to you in slide 2. It does look a bit messy, but I promise you it's probably one of the easiest setups. So what we have here, we have the LEDs coming at the top, then each of the LEDs is connected with the resistor, and then the resistor is going into the minus line here, and then the minus line goes into the Arduino itself, and so we ground it that way rather than using a lot of grounds, plus we don't have space for it. So that's what we meant by you can bridge them. As you can see here, there's only 5 slots. However, we need to ground it on top of it, so we need 6 slots. So we used 4 slots here, then we bridged it with the other one, and then from the other one we actually grounded here. This is about it for this project, for this exercise. I hope you enjoyed it. So I hope that was clear enough, and if you have any further questions, feel free to ask them in the Face group as well. Just post them there and we'll give you an answer within 24 hours of you posting it. As I said, I hope the exercise was a little bit fun, at least for you. And as I said, the more we progress, the funner it will get, and the projects themselves will become more complicated and more interesting. Now I want to talk to you about common operators. And what they do, they compare the variable on the left, i.e., let's say, some sort of a statement or variable which you declared, let's say LED1, which is classed as a variable on the left with the value, or a variable on the right of the operator. So on each of the sides you can have, let's say, LED1 does not equal LED2. And the very common operators that we have, less than, which is indicated with an arrow to the left, and less than or equal to with the operator arrow to the left, equals, greater than, which is arrow to the right, greater than or equal to, arrow to the right, with the equal sign to the right itself. Then equal we define by 2 equal signs, and then we have not equal, which is defined by exclamation mark and equal sign, which means if they're not equal to each other, execute some sort of a command. At the moment, might seem a bit pointless to you. However, those are very common operators, and they will be used extensively as the projects progress and become more complicated, and when they involve more logic of what we want the Arduino to do for us. Then we get the maths operators, the very simple one, addition defined by a plus sign. We have subtraction, which is defined by the minus sign, multiplication, which is defined by a star, and then division, which is defined by a single forward slash. Don't forget, double forward slash will give you a comment after the double forward slash. And then there's a little bit less popular operators like increment, decrement, and then we have the logical gates. And as I said, the logical gates will be used in much more complicated projects, within much more complicated projects, and we will get to them the further we progress with this course. So, for the last part of this presentation, we want to talk about the serial port. Uh, there's pretty much three main questions which we wanted to define. What is a serial port? What is it used for? And why do we use it? So first of all, to be able to access the serial port on the Arduino and to use it in the Arduino IDE, the Arduino software, we need to define it, and it always gets defined by one simple line, which is serial.begin open bracket 9600 close bracket semicolon. The 9600, it defines the frequency and channel it uses to communicate on that serial port, and then we can actually visually see, with the help of the IDE of Arduino, what is happening within our board. So what is a serial port? It is, as I've already mentioned, it is a function within the Arduino IDE, and we're just gonna show you an example in just a moment to how it operates, in a sense, where you can find it within the software. And it's not a very exciting function, put it that way. It's not very visual, but it's very helpful. Why do we use it? We really use it to monitor the output the Arduino gives. It's very helpful when you build a project. For example, you want to make sure before a lot of projects, for example, you need to solder it. Let's say it's a little car, and just to make sure that the Arduino does what you want it to do, you will run it through a serial port, make sure that it gives you the correct information back, or the information which you're expecting, and then you put it together. Otherwise, if you put it together and you find that it's not doing what you want it to do, then you need to take it all apart, and then it can be a mess. And for example, for some projects where there's soldering involved, it becomes much more difficult. So it is, in a sense, a testing tool which is very helpful and will be used intensively in our next exercises. So, as I said, why do we use it? Again, we use it just to make sure that everything works correctly, everything is in place. And just to show you quickly in the IDE itself how it will look like. So the serial.begin, the open bracket, close bracket 9600 will always be in void setup. It will never go into the void loop. You don't need to loop that function. It goes in the void setup, and that tells the Arduino it can communicate with the IDE through that channel. You can find it through tools, and in tools you will be able to open it and find the serial monitor. You can also use the quick access keys Control Shift M, and it opens the actual serial port for you now. What we at the moment we're not gonna see anything, and this is because there's no output in a sense. We're not measuring anything. We're not wanted to show us anything. We only have the lights blinking in a sequence, so it's not gonna show anything as of yet. However, in the next exercise, which is gonna come out tomorrow, we're gonna do them quite rapidly. There will be about 4 to 5 presentations per week, and we want you to try and complete all of them. It's not gonna take a lot of your time, however. We want to make sure you're prepared when you come and visit us, so we can do very cool and very fun stuff in England. This is it for this presentation. I hope you enjoyed it. If you have any questions, any comments, please feel free and leave them in the Facebook group. And as I said, we'll be able to respond to them within 24 hours, so you don't have to wait for a long time. Thank you very much.